Hello my dear students, today we are in lecture number 21. I hope students you have solved 2 unit of my first assignment I have given you. Now my dear students, in today's lecture we will try to find out the potential of different bodies. I am B.S. Pandey, a student. The first question today will take, it is the potential due to charge rod. Okay, it is potential due to charged rod. Okay, my dear student, suppose this is a rod of linear charge density lambda. It is the charge per unit length. We have studied already. We have to find potential at a point P. Okay, suppose if length is L, we have to find potential at a distance A. What we have done, my dear student? So we took elemental, okay, elemental section of this rod, suppose of dx length, which is at x distance. Okay, this is at x distance, dx length. We can find the charge of this elemental length as lambda dx. I hope, student, you have worked hard at your home so that you can understand this is very easy for you now. To find potential at point P, now this is elemental charge dq, like point charge at x distance. We can write potential V at P as kq. Now we are having charge is dq divided by x. Okay, my dear student. Now this is k, dq is nothing but the lambda dx over x, and it is Vp. The very simple question, student, we are dealing today. So the Vp, it is k lambda constant. You have to integrate 1 over x. Okay, now the integration limit, you have to put the limit, since from this point the potential starts, that is from A. At A the potential will be how much? It will be 0. But as you move from A to A plus L, you will get the total rod and the potential will be maximum, that you have to find out actually V. So my dear students, V minus 0, it will be the V, that is after putting the limits. It is k times lambda and 1 over x. Of course it is natural log x, and you have to put the limits. Sorry, here the limit was from A to A plus L, A plus L. So the answer will be k lambda ln A plus L minus ln A, and you can write here the k lambda natural log here A plus L by A. It is V. Okay, my dear student. So this is the potential due to rod, which is very simple. Kindly note down, my dear student. Now if you understand this one, I'm giving you homework. You have to derive the potential by yourself. A simple question, not very tough, but few questions I always try to leave in this classroom, that is online program, so that you can work hard at your home. Now you have to find the potential of the same linear charge density rod, same length, lambda, it is given, but you have to find the potential not at this point but the perpendicular up at this point. This is the P and the length is same A. You have to find potential at point P, which is perpendicular to the rod. Student, if you will get the answer of this question, you can also find if this rod is placed in such a way and the point is actually not the perpendicular. If point is at theta, okay, if point is at an angle theta, then you can find the potential due to this rod of length L, linear charge density lambda, of this one also the lambda. So you can solve such type of question by yourself, my dear students. Now we'll move forward and we'll try to find out the potential due to cell. Okay, that is also very important. As I given you, this one is the homework. Another homework I'm giving you. Take another homework. This is also very simple. Try to find out the potential due to this ring. At A, R is the radius of the ring. It is positively charged. Lambda is the linear charge density. At A, radius R, you have to find potential at this point P. Remember, why you solve the potential scale quantity, you don't have to take the vector calculation. Okay, so this would be easy. If you will try to solve this question, that would be easy. In case if you're not able, you can leave in comment or you can ask in group. Otherwise, the number of question, I'm having the time limits over here. The number of question I'll discuss in classroom program, my dear students. Okay, now the next application that you have to face in your board examination, potential due to charged cell. Okay, is a conducting shell. You have to plot the graph also. Potential due to charged cell. Potential due to charged cell. My dear student, this is the using this section for the diagram. This is the cell, suppose of radius r. You have to find the potential at 3 points. I'm generalizing, okay? You have to find the potential at 3 points. One point P, suppose this distance is x, that is case 1, it is outside. Okay, that is x is greater than r, outside the cell. Remember, this is cell and this cell is charged. Sigma is the surface charge density. Sigma is the charge per unit area and it is the surface charge density, my dear students. How we will solve the potential? As we have discussed, to find the electric field, we first draw the Gaussian surface, etc., and then we conclude to the electric field. We'll use here the relation between that we have studied in last lecture, the relation between electric field and potential. We are going to use over here. As we know that electric field can be written minus dV by dx, okay, or dV is minus E dx. Am I right? Okay, we have to find potential dV. Okay, my dear student, here minus E, that is the electric field. Try to recall what the electric field we have written over there. Electric field, yes, it was kq by outside the cell. Try to remember, it was kq by x square. Now times dx. We have to find the electric potential for this case. Here minus kq will be the constant. We have to take out 1 by x square dx from 0 to x, because we are finding over here and we have to find the potential as we are moving over here, the potential at this point dv. Now the potential, actually the one integral we are not going to find out here the exact, we are finding potential at point P. Now what will the integration? Is the KQ minus KQ, and the integration of 1 by x square, it will be minus 1 by x. So it is minus 1 plus KQ over x. So this is the potential outside. I'm writing here the potential outside, it is KQ by x. Okay, this is the outside. Now case 2. Case 2. As we will move and to the surface, what will be the potential, my dear students? So the potential at the surface of conductor, as you will draw a Gaussian surface, the charge enclosed will be the same as the charge enclosed by this surface. Okay, so what will change actually? Only you will find the change in this radius. K is constant, charge remain constant, x will change. So at the surface you will find V, at the surface you will find the same as, but KQ by R. Remember, it is KQ by R. Since R is smaller than x, so this potential will larger. As you move away from the center of the cell, potential will decrease. Yes. Now at this point we are finding that is inside the cell. Now case 3. Case 3. Inside. What was that case? The second case was, we have written the x is equals to R at the surface. At the surface. But the third case we are dealing here, inside the cell. It means x is less than R inside the cell. Suppose this point, at this point. Okay, we know again E is equals to minus dV by dx. Since we know that electric field is how much? 0. Since the charge enclosed will be 0, so the electric field also 0. If it is 0, then 0 equals to dV by dx. And we are getting derivative of V as 0. Derivative of V as 0. If we are getting derivative of V as 0, then we can write this V as constant. For any constant function, we get derivative 0. If V is constant, then only we will have this derivative as 0. It means V will be constant. Up to what length? Where this V will be constant? Actually, my dear students, you can say, you can understand, inside the sphere, everywhere the electric field will be 0. So everywhere the potential will be same. And how much it would be? Yes, same. But how much? So this how much? Actually, just outside the Gaussian surface, or just at the surface of conductor, you are getting the potential how much? KQ by R. So just inside it is constant and approx equals to this one. So it is constant, but it is equal to KQ by R. Okay, my dear student. So you are getting this is the maximum potential. As you are moving to the center even, this is KQ by R. Everywhere it is constant. And remember, this R you are not considering. Actually, you are going in, the potential is not decreasing. Since inside the cell electric field is 0, that's why this potential is constant. And that potential constant how much? So it equals to KQ by R. Now students, you will be asked to draw the graph between this potential and position. Okay, so we are going to kindly note down, this was the second case, the answer second case, and this is the third case. Okay, I'm rubbing this one, kindly note down in your notebook. Now the graph. So this is the center. I'm plotting the graph. Okay, I'm plotting the graph. Amazing. And this is the length. This R is 0 and this is R. As you are moving, this is X in meter. and this is the potential in volt. Okay, yes, joule per coulomb. Here what will be the potential at 0? What is the potential? Kq by r. At 0 the potential is kq by r. It means not 0. Suppose this is the kq by r, this is the kq by r. As you are moving towards the surface of the cell, whether the potential increasing or decreasing? The answer is no, it is not changing, it is constant up to the surface. So the graph will go straight. After that, what is the potential? Yes, after that we are moving away from the surface, we are getting potential decreasing. Now the relation will be from the equation 1, we can say this potential outside, it is V inversely proportional to x. So inversely proportional to x will be the graph like this one. So this is the graph of potential versus position due to cell. Okay, my dear student. Okay, now the example, I'm rubbing this one. One example I'm giving you. This is important also. Suppose a two cell of different shape, as we have studied in induction, the charge distribution of the identical shape cell. Okay, suppose we are taking here the example. In the two cell we are taking, one is this one and then is this one. The cell A, cell B. Suppose radius R1, radius R2. This is the conductor and this is the conducting cell. Now the student, suppose if I'll ask the question that which cell have the higher potential, so you can say easily the potential if it is not connected with the conductor. So the cell having the smaller radius will have the high potential. Okay, it will have high potential. There are number of factors that depends, okay, that affect the potential, but here one by one we will discuss. But here we have to actually correlate with the charge. Suppose the charge is given on this conductor as Q and you have to find the charge on this particular sphere. What are given? The given quantities are charge on this cell, radius of this cell and radius of this cell. You have to find charge on this cell. As soon as you will connect the cell with the conductor, what will happen? As you will connect the conductor with the cell, remember there will be no flow of charge. Instantly the charge will flow, but at an instant the potential becomes equal. Okay, the potential will be equal and VA will be equals to VB. Now what is the potential of this cell? It is K. Right now we have derived KQ by, okay, KQ by R1 and VB, potential of this one, KQ by R2. Okay, so you can write here the K will be cancelled out. Q by R1 equals to Q by R2, or you can also write the small q as Q times R2 by R1. So this will be the charge on this cell. There will be number of question you will be asked, okay, to solve. So in this way you can attempt the question. Now the next example, my dear student. This is the very important example today I am dealing with, my dear student. Okay, now the next example. I hope, my dear students, you are able to see by this reading. Now the next example, if you can write, my dear students, try to write down the question. I'm just drawing the question. The question is, if n charge droplets, okay, these are the charge droplets, radius is r and charge on each droplets is q. How many droplets are there? N. If n charge droplets of radius r and charge q, okay, coalesce, mixed together, coalesce to form a single drop. These are coalesce to form a single drop. Suppose its radius is r. Okay, what will be the charge of this drop? We will discuss. So if n charge droplets of radius r and charge q coalesce to form a single drop, find potential of bigger drop. You have to find potential of this bigger drop. Nothing else is given. Remember, so note down this one. I'm solving such type of question. I hope you have written the question. If you have not written, kindly just rewind your video and write down the question. Now, how you will solve such type of question? First, we are finding the charge, my dear students. What will be the charge over there? Suppose this charge is q. So according to conservation of charge, since charge can be added algebraically, it has the additive nature. So we can write here the charge is, if the two drops will coalesce, the charge will be 2q, but n drops are coalescing, so the charge will be n times q. I hope this is not very tough. Now, what about the radius actually? Suppose the volume of one droplet is small v and number of droplets are n, so the total volume, since the volume will also conserve, volume will not change, so the volume of this bigger drop, that is the capital V, okay, this capital V will be equals the n times and the volume of one droplet volume, suppose v dash, so it will be v dash. What you will get actually from here? You will get the radius of the bigger drop. How? Suppose here the volume of bigger drop, we are writing 4 by 3 pi rq is equals to n times 4 by 3 pi rq. Okay, so this rq will be equals, it will be cancel out, this will be the cancel out, so n times rq, or this r can be written as, if you just remove this cubic, then this will be the r times cubic root n 1 by 3. This is r. Okay, my dear student. Now we have to find the potential. We have radius of the bigger drop. We have charge of the bigger drop. So we can write the potential of bigger drop as V. Remember, this is the V potential we have written here. Let me write the volume I'm representing by the V bar. Okay, so that you will not confuse. Now the potential, the formula of potential is what? Try to recall. Yes, kq by r. So the kq, what is the charge over here? Q, it is n times q by r. What is the radius? We have derived r n 1 by 3. Now it is the simple calculation you can do. K q n, this one divided by r, we can write here the n to the power 1, and here, so the 1 minus 1 by 3. So this will be k q by r n to the power 2 by 3. Are you getting? Kq by r n to the power 2 by 3. 1 minus 1 by 3. And this is the potential. Now, rewind this video 2 times, 3 times till you have not understand. If you are not getting, then you will leave the comment. I'm giving you a question, simple question for your practice, so that this concept written in your brain. Okay, the very simple question, my dear student. This will be your homework. Okay, after next class you will show this homework after completion. In this system, small droplets, okay, 27. So the 27 charged droplets, the charge of each droplet Q is 1 picocoulomb. Okay, my dear students, picocoulomb, I've taught in the first class pico, it means the 10 power minus 12. So the 1 picocoulomb of each droplet are coalesced to form a big drop. You have to find potential of the same question, है ना? Exactly same question. Potential of bigger drop. The radius of each droplet is 1 millimeter. For your simplicity, all the data I've given, the very simple. Okay, my dear student. So this is your question. Now another question you might have to face, it is potential due to concentric cell, my dear student. Okay, potential due to concentric cell. Potential due to concentric. A very simple example we are taking. Suppose a cell and another cell, concentric cell. Okay, this two cell. Radius of this one R1 and this R2. Okay, now the charges are given over this one Q1 and Q2. You have to find potential on 1 and 2. Okay, 1 and 2. How you will write? So the potential on 1 you have to write in this way. Try to learn. Okay, at 1 the potential due to this particular cell will be K. Okay, Q1 divided by R1. But at this point, this is maintaining some potential, that is the K Q1 by R1. But inside this cell, the capital one, okay, the bigger cell, inside this cell, we know that the potential is constant everywhere, and it is how much? It is equals to the potential which is at the surface of this cell. So this will be also sum up, and it is K, how much? Q2 by R2. So this is the net potential where at this point 1. But if we talk about the potential at point 2, okay, so the potential at point 2, we are going to find out the potential at point 2. Now at 2, at this point, the potential due to this cell, it will be how much? Potential due to this cell, it will be K Q2 by R2. But as we know that outside the cell there will be potential, as we have derived. Outside the cell, the potential at this distance, due to this cell there will be a potential at this point also. So due to this cell, the potential will be K, and the charge of this cell, how much? Q1 divided by, we have to find potential due to this cell at this point, because we are finding potential at 2. So at this point, the total distance will be how much? It is R2. So it will be R2. Directly you can also write, my dear student, as K by R2 Q1 plus Q2. There are a number of different methods you can solve such type of question. Okay, now the another question I'm giving you, and you will just use your brain to solve question. I'm rubbing this. Now my dear student, another question I'm giving you. Suppose you are having this with the example. I'll solve. The 3 concentric cell. Okay, radius R1, R2, R3, or suppose the radius A, B, C. Okay, and the charge is given Q1, Q2, Q3, and you have to find the potential at 1, 2, 3. So what will the potential at 1, 2, 3? Pause your video and try to write the answer. Okay, my dear students, I am also writing the answer by pausing the video. Now student, look at here and compare your answer. At this point 1, at 1, due to this cell, it will be the K Q1 by A, but this cell is inside the cell 2 and 3 also. Due to 2, it will be the K Q2 by B, K Q2 by B, and due to the third cell, inside this cell everywhere the potential will be equal to the potential which is at the surface, and it is the kq3 by c. Now the second one, at this point if you will find the potential, at this point the potential will be potential due to this cell itself, it is kq2 by b, it is kq2 by b. But at this point this cell will also maintain some potential, and this is maintaining the potential at this point which is b distance away, it is kq1 by b, kq1 by b, and this point is inside the third cell, so the third cell will maintain the potential, it is kq3 by c, which is the potential at this cell. Now at the point 3 the potential will be at point 3, at 3 due to this cell will be how much, kq3 by c, kq3 by c, but due to first and second cell there will be potential which is kq1 by c and kq2 by c. So this is the potential. This is all about the today lecture, students. Thank you very much.